Figure 6 shows a quadrilateral ABCD in a horizontal plane in which AB is 10 meter and the angles, this is 90 degree, and this angle DCB is also 90 degree, and we have another angle, this is 60 degree, and this is 35 degree. We have to do every sum in 3 significant figure. Okay, for doing these type of sums, always draw a miniature right angle triangle, so BD. So BD is in this right angle triangle, so let me draw this miniature triangle. So this is A, D, and this is B. So this is hypotenuse is 10 meter, this is 60, and we're looking for BD. So mention the triangle. In triangle ADB, mention the 90 degree in the middle. I can use this ratio of sine. So sine 60 degree is opposite, which is BD, divided by hypotenuse, which is 10. So katoa. Therefore, BD equals to 10 sine 60 degree, and that turns out to be, so 10 times sine 60. So 0.866025. So 3 significant figure is 0.866, but we have to write more accurate. So 0.866025 equals to 0.866 meter. We have to write the value because otherwise there would be a rounding off error in the next sum. So question number B. Now that we know BD, we have to find CD. Let's move on to the next triangle. So this time the miniature triangle would be this one. So DC, here is the 90 degree, and this is B. The hypotenuse here is BD, which we found in the previous sum, and this angle is 35. So in order to find CD, so in triangle DCB, put the 90 degree in the middle, that's the convention. So here in order to find CD, we have to use the cos. So cos 35 is adjacent CD divided by hypotenuse BD. So BD we just found is 8.66025. Therefore, CD would be 8.66025 cos 35, and that turns out to be times cos 35. That is 7.094 7.09 meter. Question number C. Here we have to find BC. It's in the same triangle, so that is not a problem. Triangle BCD. This time we can use sine. So sine 35 is the opposite is BC divided by hypotenuse is BD, which we found in the previous sum, 8.66025. Therefore, BC equals to 8.66025 sine 35. So that turns out to be 8.66025 into sine 35. 4.9673. 4.9673. 15. So 15. So that means it would be 4.97 meter. So that would be the answer. So question number D. Now the question is, there is a vertical pole. The 2D sum now becomes a 3D sum. So at the point D, there is a vertical pole which is rising above the ground. It is placed at the corner D of the quadrilateral ABCD. The angle of elevation of P from D is 35 degrees. What happens? So here there is a vertical pole which is rising above the ground and it's making an angle with the ground. Remember, the angle of elevation is always with the ground and its horizontal side. So that angle of elevation from B to the top of the pole is 25 degrees. This is 25 degrees. So the right angle triangle that we have to use is triangle PDE. Okay. Let's draw a little triangle in the question B. This is the right angle triangle. Remember, this is not above the ground. B 90 degree. This angle is 25. From the previous sum, we know BB is 8.665, and we have to find the height of BD. We can find this from this right angle triangle BDC. So we have to find BD. We can use the tan ratio. The tan 25 equals the opposite BD divided by adjacent 8.66025. That makes it therefore PD equals to 8.66025 tan 25. Remember to write this number before the trigonometric ratio. So 8.66025 times tan 25. This is 4.0383. 4.0383. Up to 3 significant figure. 4.04 meter is the answer. The next question is a second vertical pole CQ of length 6 meter is placed at C. So now at the point C, at this point, a second vertical pole is placed. So this is Q and this is 6 meter. So this is 6 meters, so this is above the ground from C. And it is mentioned that we have to calculate the angle of elevation of Q from B. So remember, this is above the ground. This is now in 3D, so we have to calculate this. We have to calculate this angle now. The triangle that we'll be using now would be QCB. So QCB. So question number E. So the triangle QC and this is B. So this is the 3D above the ground triangle. QC is 6 meter we know. And in the previous sum, we already know the length of BC. We found the length of BC. So here, the length of BC is 4.9673. So this is 4.9673. Okay, so in triangle QCB, so the ratio we can use is tan theta. So tan, let me call this theta, the angle of elevation. So tan theta equals to opposite divided by adjacent, 4.9673. So we can write this down directly using the calculator. So that would be 6 divided by 4.9673. That is 1.2079. 1.2079. Remember, the value of sine ratio and cosine ratio cannot be more than 1. Tan ratio can be. So therefore, theta equals to tan inverse of 1.2079, and that comes to be tan inverse of this 50.379. Since I might not be needing this, I'm going to write this to figure directly. 50.4. Since I don't need this angle anymore. Question number F. Calculate the angle of PBC. So PBC. So we now have, this is P above the ground. This is B. This is on the ground. C. So we have a different sort of a triangle now. If you think of this triangle this is above the ground, and this is going on the ground, and this is also going towards the ground. So this is the triangle that we have, PBC. For this triangle, finding the angle PBC, we need BC then let's take a look what's going on. So here we have BCD on the ground. P is above the ground. Remember, it's a pole that is a vertical pole put at D, so it is above the ground. Then Q is another pole above the ground from C. Then we saw that we have uh, P and B joined, so it makes another plane. So when we have this, so we have this right angle triangle. So this is P, and when we join this, so the angle of elevation is always with the ground. So this angle is 25 degree. We saw that. Then we saw uh, this part where we take Q. We take Q, and this is above the ground from C, and we join this D, and we also found this. So now the question is that we have to do. Let's join this. So this is our triangle here on the ground, BCD. And now what we have to do, we have to join P with B. This is already joined. Then we have to join P with C. So this is what, now we are talking about this plane over here. So we have PBC. Let me change the color. So this is what we have. So with this PBC, what we have to find this angle PBC, angle of this plane. Let me remove these planes so that you can see this better. If I remove this and this, okay. So this is the plane that we have here. Now PBC, if you notice, if this plane over here, this is 90 degree. This plane over here is 90 degree. So if this PCD, this is 90 degree, and this is, since this is another plane, so this would be 90 degree to this plane over here. So this angle PCD should be 90 degree. It might not be obvious if you don't see this 3D model, that if you have a rectangular plane on this side and this is the diagonal of that plane, of that rectangular plane, so, and this, we have another plane over here, so this is 90 degree also. So then this side, this PC should be 90 degree to the other plane. So since it might not be obvious, if it was obvious, then you can do the sum very easily. So PBC, if you want to find the angle PBC, you know already BC from the previous sum. All you have to do is PC divided by BC, tan theta. You can use tan theta and find the angle. So let's try this part first. So let's draw the triangle here. So question number F, we have this right angle triangle. Remember, in Maths B, it has to be a right angle triangle, or it has to be an isosceles triangle. Otherwise, it will not work. So this is C, and this is B. So previously, we found that BC is 4.9673. So 4.9673. And PC here, we have to find from, we can use the previous triangle. For finding PC, we can use this triangle. So PDC. So we can do that. We can use the triangle PDC. So we can draw another triangle. So for finding PC, let me use the triangle PDC. So we know what PD is. PD is 4.0383. This is what PD is. CD is, or DC is, which is 7.09406. So 7.09406. So using Pythagorean theorem, we can find this. So in triangle PDC, we can write PC square equals to 4.0383 squared plus 7.09406 squared. So therefore, PC equals to square root of, so let me do the calculation. It would be 4.0383 squared plus 7.09406 squared, and we get 66.6336. 66.633 66.6. So we get 66.6336. Square root of that is going to be 8.1629. 8.1629. That is PC. 8.1629 is PC. Now we can use the value of PC. 8.1629. Now we can write for this angle in triangle PCB, tan theta equals to opposite 8.1629 divided by 4.9673. Therefore, this is going to be tan inverse of, let me calculate this, 8.1629 divided by 4.9673. That would be 1.6433. So 1.6433. So tan inverse of that is, so tan inverse of that is equals to 58.7 degree. 58.7 degree, the three significant figure. Now, one thing might not be obvious. You have to understand that when you're looking at this diagram, it might not be obvious that this is PCB is indeed 90 degree. It only becomes obvious when you take a look from the 3D point of view that this indeed, since this is 90 degree and this plane is 90 degree to the other plane BC, so then this side would definitely be 90 degrees. So it is obvious from here, but from the point of view of this question, it might not be obvious. So it is fine. If this is not obvious that PCB is 90 degree, you can go right ahead and find PB separately, PC separately. You know BC already, and for finding this angle, you can use the cosine rule if you want to. That is always an option if you don't, if it's not clear to you. So you can use the cosine rule because you know PC, you can figure out PB, you know BC. So using the cosine rule, you can easily find out. So remember, cosine rule is applicable, but what they say in the syllabus, you don't have to. But if you cannot figure it out, you can use the cosine rule.